All right, class. So today we are going to do more real number system, and then we're going to go on to estimating roots. Okay. All right. So the first thing I asked you to do was to see if you could put these numbers in the appropriate categories. So we have this fraction 4/5. 4/5 we know is a real number, so we're going to put it here. All of the numbers are real numbers. So really all of the numbers should have went here. Okay, so we put all of the numbers under real numbers. Okay. This first number is a real number, but it's also rational because it is a fraction itself. So we got 4/5 is rational. Mark that out because that's all it is real and rational because it's a fraction. -18 is real. It's also rational because you can write it as a fraction. And it's also an integer, -18. It is not a whole number, okay? So that's it. 0 is, of course, a real number. All numbers are real numbers. 0 can be written as a fraction. 0 over any number is equal to 0. 0 is also an integer, and 0 is also a whole number, okay? The square root of 5, let's type the square root of 5 in, see if it's a decimal. Look at this. Second x squared and 5. It is a decimal. So since this square root, the answer is a decimal, it's irrational. And if a number is irrational, all it can be is real and irrational. That's it. Okay. Negative half, it is a fraction. So it's definitely a real number, but it's also rational. Okay. It is not an integer. It is not a whole number. If a number is rational, it can't be both rational and irrational. It's either one or the other. Okay. This is a decimal. You can write this decimal as a fraction because it stops as a terminating decimal. So that makes it rational. It can be written as a fraction. Okay. It's not an integer and it's not a whole number because decimals are not integers or whole numbers. 5, of course, is real. It's rational because 5 can be written as a fraction. Okay. 5 can be written as a fraction. 5 is also an integer. It doesn't have a fraction or a decimal attached to it. And 5 is also a whole number. Pi. Of course, every number is a real number. Pi is irrational because it's a decimal that is non-terminating. That decimal goes on and on and on without a pattern as to how it repeats, and you don't know what number is coming next. So pi is also irrational. The next number is a repeated decimal. I do know what number is coming next, so I can write that as a fraction. So here we have 2.513, and all three numbers are repeating. All three numbers are repeating. Okay. It is not an integer because decimals are not integers. So you can't write that as an integer. Okay. The next number, this last number, has the little dots on the end as a decimal. That means it is continuing without end. It goes on and on and on forever, but you don't know what number is coming next. So this number here is irrational. Okay. Any questions about that? All right. So let's look at anyone still copying before I move on. Okay. I'll pause for the calls. Let me know when you're finished. All right. So this is what I want you to do with number 2 and 3. I'm going to put you into a breakout group. I'm going to give you all 5 minutes to answer number 2 and number 3. Okay, and then we'll quickly just go over them. So I'm gonna give you exactly 5 minutes in your group. Please make sure that you're plugged in. Please make sure you keep your cameras on. I am going to give you participation for this. The expectation is that you have your camera on and that you're communicating with your group. Okay? All right. I'm going to pause my video and put you in groups. Okay? And I probably should say that again. We already answered these questions. You did this in your group. So now we're going to turn over and we're going to do estimating roots. Okay? We're going to use perfect squares to estimate roots. We're going to put, actually, we're going to put that in our notebook. Okay? So let's take out our notebook real quick because we need to know what those perfect squares are. So this is going to be page 2. This is going to be page 2. All right, I'm going to pause for the calls so that those of you that don't have your notebooks can get your notebooks out. Okay, so this is Q4. This is page 2. And we're estimating roots. To the nearest whole number. Okay? We're estimating roots, nearest whole number. In order to estimate roots, you must first know your perfect square roots. Okay? So we're going to list our perfect square roots. And some you should know by heart. Okay? This is how you create your perfect roots. You ask yourself, we're going to go with the first one. 1 times 1. What's 1 times 1? Any 1. Therefore, the square root of 1 is a perfect square root because it is equal to the whole number 1. So this is a perfect square root, the square root of 1. Let's do the next perfect square root. Let's do 2 times 2. What is 2 times 2? Anybody? Hello? 4. So we have the square root of 4 is equal to 2. Why? Because 2 times 2, 2 when you multiply it times itself is equal to 4. Okay. The next perfect square root is 3 times 3. What is 3 times 3? 9. Okay. So the square root of 9 is equal to 3. Okay. I'm going to pause. I got a question in the chat. Okay. Now we have the next one. 4 times 4, 16. Good job. The square root of 16 is equal to 4.
I hope everybody's taking these notes because these are the ones I was talking about yesterday. That's going to be super helpful as far as identifying your perfect roots, your square roots, and your perfect roots.
Okay, so we got 5 times. That's okay, you're good. 5 times 5 is 25. The square root of 25 is equal to what then? 5. Then our next perfect square is 6 times 6, which is what? 36. So the square root of 36 is equal to 6. To make our next perfect square, we say 7 times itself. 7 times 7 is what? 49. The square root, perfect square root 49 is equal to what? 7. Good job. Then we have 8 times 8. Very good. 64. The square root of 64 is equal to what? Very good. Great job, Jordan. Then we have 9 times 9. 81. Good job. The square root of 81 is equal to what? 9. Then we have 10 times 10 is what? 100. So the square root of 100 is 10. Let me see if I have to go higher with any of these. Yeah, just a little bit higher. Okay. Then we have 11 times 11. What's 11 times 11? 121. Some of y'all might have to start pulling out your calculator, right? Which is equal to 11. What is 12 times 12? 144. Good job. The square root of 144 is what? 12. Excellent. Then we have 13 times 13. What's 13 times 13? Try again. Type it in, y'all. I'm gonna pause. What is it? 169. Good job. 169. The square root of 169 is what then? 13. Good job. All right. What's 14 times 14? 196. So the square root of 196 is equal to what? 14. Good job. Okay. Then we got 15 times 15. What's 15 times 15? Not quite. Somebody type it in. See what you get. 225. Good job. So the square root of 225 is going to be 15. Okay? All right, and you should know those by heart. I'm gonna go ahead and do 20 because we should know up to 20. Let's do 16 times 16. What's 16 times 16? 256. Good job. The square root of 256 is then equal to 16. All right, somebody be typing. What's 17 times 17? Come on. What's 17 times 17? You already know it's coming. 18 times 18 is coming. 19 times 19 is coming. Say again, babe. I couldn't hear you. I'm sorry. 306. Okay. No, that's not right. Type it in. Come on, y'all. I'll pause for you. 289. Okay. The square root of 289 is equal to 17. All right. What about 18 times 18? Say again, baby. 324. Okay. So the square root of 324 is 18. What about 19 times 19? Come on. 19 times 9. Type it in. 361. So the square root of 361 is what? 19. And what about 20 times 20? 400. So the square root of 400 is what? 20. Okay. If this is gonna make this concept and some other concepts so much easier for you when you know these by heart. Okay? So we're gonna use these to estimate roots. Okay, I'll pause to give you a chance to write those down. So now we're gonna estimate, all right? We're gonna estimate the square root of 31. So what we're gonna do is find what two perfect roots is 31 in between. So look, it's not between 1 and 4, or 4 and 9, or 9 and 16, or 16 and 25, but 31 is between 25 and 36. So that's what we're going to write here. The square root, it falls between the square root of 25 and the square root of 36. So please write that on the line, okay? That's where the square root of 31 is in between these two numbers. Is it closer to 25 or 36? Okay, it's closer to 36. All right. So, but it's closest to the square root of 36. So the square root of 36 is equal to what number? What did we say the square root of 36 is equal to? 6. So we're going to round it to 6. Our answer is going to be 6. Okay. This is going to be our answer here. All right. So let's do number 2. Now we're going to round the square root of 53. So we're going to figure out what two perfect squares is the square root of 53 in between. So it's not between 1 and 4. It's not between here, 4 and 9, or 9 and 16, or 16 and 25, or 25 and 36, or 36 and 49, but it is between 49 and 64. Do you see that? It's between 53 is between 49 and 64. So that's what we're going to write. The square root of 49 and the square root of 64. Which one is 53 closest to? Is 53 closer to 49 or is it closer to 64?
It's closest to 49.
It's closer to 49. And what's the square root of 49 equal to? 7. So our answer here is going to be 7. Good job. Okay. See if you can do number 3 on your own and then submit this. So all we have done in this assignment, and we're going to submit it, is we've done this first page right here. We did this yesterday. Okay. We did the second page with our group, this right here. Okay. And then on this third page, we only did numbers 1, 2, and 3. And then I need you to submit this assignment. Any questions, comments, or concerns? Okay. Are you sure there are no questions before I stop the video? Okay, I'm going to stop the video here.